So now we are going to discuss about how we can design an asynchronous up-down counter. So in the previous discussions we have seen how to design an up counter and then how to design a down counter. So we know how to design both these cases separately. And for a single circuitry, how we can count, how it will work as an up counter as well as a down counter. That is what we are going to see. Okay, so we know that this particular setup has to, or whatever flip-flops we are connecting, it has to work as an up counter in one situation and I have to work it as a down counter in another situation. So for selecting that situation, I am using a control input, and that control input is known as, here I am using this as M. M is nothing but mode control signal. Okay, so this M is a mode control signal, and here we can say that if I am taking this M also as an input, and also we are having Q and Q bar as the output of every flip-flop. So for these three we can have various combinations. So this is 0 0 0 0 0 1 0 1 0 0 1 1. That is, here M is equal to 0, right? Then next case is, this is 1 0 0 1 0 1 1 1 0 and 1 1 1. So this is where M is equal to 1. Okay, so M is equal to 0 and M is equal to 1. And here I am assuming that when M is equal to 0, I am connecting Q output to the clock of the next flip-flop. We know that if you are using this Q and Q bar, by selecting Q and Q bar in a different way, you can you can use the flip-flop function as either as up counting or as down counting. So if you are connecting Q to the next flip-flop, if it is a negative triggered flip-flop, then it will count up, or it will work as an up counter. And if you are connecting Q bar to the clock, then it will work as a down counter. So what we have to do is we have to choose either Q or Q bar, right? So depending upon this control signal or this control input, I will choose either Q or Q bar. Okay, so that is what we are going to see here. Okay. Okay, now we can see how this I am using a control input, and this control input is M, and depending upon the value of M, I am choosing either Q or Q bar as the clock for the next cycle, next flip-flop. So we know that if you are choosing Q, and if it is an active or negative registered flip-flop, and if I am choosing Q as the clock for the next flip-flop, then it will behave like an up counter, right? So if M is equal to 0 and if you are choosing Q as output, it will behave like an up counter. So M is equal to 0 means it is an up counting. So if I want to count up, I have to choose Q as the next input. So what is Q? 0 0. This is the output should be 0 0 1 1. Okay, so I have to, if M is equal to 0, I have to pass Q, or I have to connect Q to the clock of the next flip-flop. Then what happens when M is equal to 1? When M is equal to 1, I have to connect Q bar to the clock of the next input. So when M is equal to 1, I have to connect Q bar. What is Q bar? Q bar is 0 1 0 1. So 0 1 0 1 I have to connect. So if you are connecting Q bar to the next flip-flop as a clock, then it will behave like a down counter. Okay, so this is what we are going to solve now. So M is equal to 0, M is the control input. You can see here M is equal to 0. So here all 4 cases M is equal to 1. So when M is equal to 0, I am taking Q as the output, and when M is equal to 1, I am taking Q bar as the output. When Q is connected to the output, it will behave like an up counter, and when Q bar is connected to the output, then it will behave like a down counter. So that is what I am going to see now. Now I have to find the equation for this Y. Okay, so I have to realize this part Y. So how we can realize? We are having 3 inputs. You will use the K-mark method for simplifying it. So we are having M, then Q and Q bar as the input, and our output is Y, and we are going to find out the equation for Y. Y equal to what is Y? Okay, so when 0, 0, 0, 0, I have to fill this values. 0, 0, 0, this is 0, 0, 1, 1. So 0, 0, 1, 1. Here it is. I hope you remember the K-mark simplification. So 0, 1, 0, 1. So this is 0, 1, 0, 1. So this is 0, 0, this is 0, 1, this is 1, 1, this is 1, 0, and this is 0, this is 1. Okay, so now I have to simplify it. So how I can club this to? This is one method of joining, and I can combine these two. Okay, these are the two methods. So what is this? If I am taking these two, this is nothing but M bar, this is 0. So M bar, this is the first term, and then this is the second term in K-mark. So what is our Y? Y is nothing but first, equation of first plus equation of second, right? Equation of first plus equation of second. So what is the equation for this? This is nothing but M0, and when you are taking Q and Q bar, Q is Y, right? Q is Y. So it is nothing but MQ, right? MQ. Or what is next? This is M bar Q. This is M bar. This is M bar 0. Okay, M bar Q. Then what is the second term? M. This is Q bar. So M Q bar. So this is the equation for Y. Okay, so we can design a circuitry such that you will get M bar Q plus M Q bar as output. So whenever you are giving this input, it will automatically select based upon the value of M. Okay, now I am going to include the circuitry in our flip-flop. Okay, so already we are having, assume that I am going to design a 3-bit up-down counter. So I need 3 flip-flops. 3 flip-flops we are having, and we are having a control input M. And since we are having M and M bar here, I have taken M and M bar. M bar is a complement of M. Okay, so these are the 2 lines, and all the flip-flops are JK flip-flops, and all the inputs are negative edge triggered. This is a negative edge triggered flop we are using, and we are having Q0 as this is a LSB, and this is a MSB. In reverse also you can write, no issue, but we have to specify it, which is MSB and which is LSB. Here also you can draw Q2, here you can put Q0. That's not an issue, but you have to specify where MSB and LSB is. Okay, now this is the case. So what we can do is, what is our output Y? How I should choose this, how I should give this clock input? Clock input should be taken based on 2 conditions. So if M is equal to 0, so if M is equal to 0, I have to choose Q0 as the clock input. And if M is equal to 1, I have to choose M is equal to 1, then I have to choose Q bar as the clock input. Okay, that is what we have decided here. M is equal to 0 means Q will be selected. M is equal to 1 means Q bar will be selected. So how I can realize that? If M is equal to 0, then I have to choose this Q0, and I have to take this as the output. Then if M is equal to 1 or M bar is equal to 0, this is M bar. So if M bar is equal to, I have to connect M bar and Q. Okay, so this is M bar, this is M bar, and Q is connected. That is one input. And our second is, if M is equal to 1, I have to choose Q bar, right? M is equal to what? I have to choose Q bar. So this is the second input, and I have to take OR of these two. To take OR of these two, OR it, and I can give it as the clock input. So what happens here? When M is equal to 0, M is equal to 0, M bar is equal to 1. So when M is equal to 0, M bar is equal to 1. So M bar is equal to 1 means this will be 1, and Q0. Q0, if it is 1, that will be given as the input. Okay, Q0 will be selected here, and that will be given as the input. What happens when M is equal to 1? When M is equal to 1, M bar is 0. So that 1 will come here. So at that time, Q0 bar will be given as the output. So whenever M is equal to 0, Q0 will be given. Whenever M is equal to 1, Q0 bar will be given as input. So it means that M is equal to 0, Q will be connected, and M is equal to 1, Q bar will be connected. So when Q is connected, it will count up, and when Q bar is connected, it will count down. Okay, this is the case. So we have drawn this. Okay, in this diagram, you need not have to include all this. For your understanding, I have written this. Okay, this is a circuit. So the same thing we can repeat here. So from M bar and Q1, we can choose select here. Then if it is 1, M is equal to 1, I have to choose Q1 bar. Then this both you can connect using an OR gate, and that can be given as the input. And this is Q2. Okay, so this is our Q0, Q1, Q2. So whenever the input M is equal to 1, Q0 will be connected here. So it will work like an up counter. When M is equal to 0, Q bar will be connected to clock input. So it will work like a down counter. So this is how we can decide an up-down 3-bit counter. Suppose you want to extend it to 4-bit counter, what you can do? You can add one more level, Q3, one more flip-flop you can add. The same circuitry you can repeat there also. Okay, so this is how we are designing 3-bit up-down